So today we are going to evaluate and graph polynomial functions. Now, the evaluating part we've already done. Okay? We've already evaluated functions at certain things. We're going to tweak how we evaluate them today. We're going to look more along the lines of end behavior than we are at a specific value. And then we're going to graph. But I'm not going to give you graph paper today because I'm not so concerned that your graphs are exact. I'm more concerned that you understand the concept of what's going on today, and so you can just sketch your graphs right in your notes today. Okay? So, no need for extra graph paper today. So, we should probably talk about this big old P word right here, polynomial. Let's talk a little bit about that. Okay? A polynomial is an expression with terms. Okay. Refresh my memory. We've already talked about the difference between an expression and an equation. What is an expression? Or what makes an expression and not an equation? Doesn't have an equal sign. So because it doesn't have an equal sign, that means we cannot solve it. So I couldn't take 6x cubed plus x squared plus 2x minus 5 and solve it for x. Okay? I can't get x equals 3 out of that. Okay? Because there's no equal sign. Another thing that I can't do is I can't graph. So I can't solve and I can't graph it. Well, if I can't solve it and I can't graph it, what can I do with a polynomial? I can simplify it. Yep, I can take the terms and I can combine like terms. What else can I do? What other things can I do with a polynomial? Or multiple polynomials? What? How? Can't, because then that brings an equal sign in. I can add them, right? What else can I do with them? Divide, subtract, and multiply. There's one more thing that I can do with them. I can evaluate them. Evaluate them, remember, is I can say, okay, I want to know what the value of this expression is, or what this polynomial is, when x is 3. So I plug 3 in for x and do all the math. Okay? So we can do all of that with them. Okay? The downfall is this, what's written in red. We can't solve, can't graph, because that's algebra. Okay? And you're in college algebra. So if I can't solve it or graph it, that just doesn't do me any good. It doesn't do us any good. So we take our polynomial and we make our polynomial into a polynomial function. Now the polynomial function, this is an equation. I can simplify polynomial functions. I can add polynomial functions. I can subtract polynomial functions. I can multiply them. I can divide them. I can evaluate them. So I can do everything in a polynomial function that I could do in a polynomial, plus I can graph them, and more importantly, I can solve them. Okay? Solutions, remember, of a function are where the function crosses the value that you want, or where the function crosses the x-axis. Okay? So if I said my polynomial function 6x cubed plus x squared plus 2x minus 5 equals 0, I would look for where that function has a value of 0. So I'd look on the graph and I'd see where it crosses the x-axis. If I said it equals 12, then I would look for where it crosses the line y equals 12. Okay? Or I could subtract 12 from the function and then see again where it crosses the x-axis. But you've done that a bunch of times. Okay? Just so that we're on the same page, we should talk about the standard form of a polynomial function, or even of a polynomial. It works in both cases. Okay? So the standard form of a polynomial function is f of x is equal to, and then I look at the biggest exponent. So I look at all the exponents, I look and see which one's the biggest, and I write that term first. Then I write the term with the next biggest exponent. And I keep doing that until I'm all the way down and I just have a number at the end. Okay. Sometimes you'll have many terms in the middle, okay, but the term with the biggest exponent comes first. The term with no variable comes last. Okay. So you might have 6 or 7 terms in between there. You might have no terms in between there. Okay? So if I scroll back up to my polynomial function here, that polynomial function is written in standard form. The term with the biggest exponent comes first, then the next term with the next biggest exponent, then the term with the next biggest exponent, and at the end, it's just a number. Okay? So, what I would like you to do now is I would like you to reorganize this polynomial function into standard form.
Can you have fractions?
So, f of x is going to equal what? Negative what? Negative. Negative 5, okay? X to the 4th. Okay, then what? Plus 2x cubed. Then what? Minus x squared was it? Yeah. Then what? Plus 4. Okay. So that is the standard form of that polynomial equation. Okay? MDX. Now, there are two key parts to that we're going to need to recognize here coming up. The first key part is this number in front of the biggest exponented term. Okay? That number is something called the lead coefficient. Okay? So the number in front of the term with the biggest exponent is called the lead coefficient. Okay? That's going to come into play later on. The second thing that's going to come into play is the biggest exponent. That we call the degree. Okay? So a little bit later on, we're going to see how we can sketch these graphs based solely on the degree and the lead coefficient. Okay? And so that you don't have to spend extra time figuring out where the points all go. Again, we're just sketching today, okay? Just looking for the general form of, or the general picture, if you will, of it. From that, then, we're going to talk about the end behavior. Okay? So, let's talk about different types of polynomial functions. Okay? So, I have a little chart. It's really not even a chart. It's just more kind of an informational type thing. Okay? So, over here on the left in black, I have the polynomial function. In the middle column, I have what the degree of that function is, and then I have the type, or what we call that type of function. Okay? So the first one is if I had f of x equals some number. So if f of x equals negative 6. We call this a constant function because the degree is 0. If I were to write this out using what we learned on Monday, we could write this out as negative 6 times x to the 0 power. Because anything to the 0 power is 1, and 1 times negative 6 is negative 6. Okay? Constant functions are horizontal lines. The next style of function is a degree. Whoa, tap the brakes. Where'd that go? Double tapped. Is a degree of 1. We've seen those before. Those are linear functions. We just spent a chapter graphing and dealing with linear functions. Okay? So linear functions, now the kicker here is it's got to be a function. Linear functions go like that, or like that. Notice how I didn't put a horizontal line in there, because that's a constant function. Notice how I didn't put in a vertical line, because that's not a function. A vertical line does not pass the vertical line test, so it's not a function. Yeah. Next one is quadratic functions. You spent a lot of time in Algebra 2 dealing with quadratic functions. Quadratic functions have a degree of 2. They look like parabolas, either opening up or opening down. Fourth quarter, we'll get into parabolas that open left and open right. But we'll save that for fourth quarter. Easy stuff. No, it's easy. Trust me. Trust me. Once in a while, you gotta trust me. Why? Just because we spend the entire fourth quarter on one chapter?
That's it?
Yeah. And it's all conic sections. It's good stuff. Okay. Next one would have a degree of 3, and we call those cubic functions. Cubic functions either start down and then work themselves up, or they start up and work themselves down. How big of a hump is in the middle is all kind of dependent on the extra terms that are going on after the cubic. Just a straight x cubed function, we'll see here in a minute, is smooth. Okay? No hump whatsoever. Oops, colored it. Oops, colored it. Oops, there it goes. Yeah. Next one is called a quartic function. A quartic function has a degree of 4. I do like me some quartics. Because they look like W's and M's. Did anybody see a pattern develop between the degree of 1 and degree of 4? And I ask because I'm wondering if I said f of x here equals x to the 5th, and f of x here equals x to the 6th, would we be able to say, well, there's a degree of 5, and I believe this is called a quintic. 6, I don't know what the title of it is, okay? But it's got a degree of 6. Okay? Would we know, could we be able to sketch what those two look like? What do you got, Colin?
We should just do 4 humps.
Like, what do you mean?
Number 5.
So, would it be going in the same directions? Like, so would it look like this?
So it would be like a quartic, just with more humps.
Like that? Is that what you're saying?
Yeah.
Do we agree with that? No? Cassie, what don't you agree with that?
One would be up and one would be down.
Oh, because you noticed that on the odd ones, it looked like they were going in opposite directions on opposite sides, right? Way back here on the linear one, one's going up, one's going down. Up and down. 3, one up, one down. One up, one down. And on 2 and 4, they were both going the same direction, right? I would agree with that pattern. So it would look like that. Or it might look like that. Okay. What about a degree of 6? What's that one going to look like? The one I drew before, the purple one? Yep. All right. So odd functions, or odd, excuse me, degree functions go in 2 directions. Jumped up. Tried to fit it in. Grr. Even degree functions go in how many directions? That's a bad G. It's like a 6. They go in the same direction. Right? The left and the right side. One might call it One Direction. Now, if I knew a One Direction song, I'd sing it for you. But I don't know a One Direction song. So I can't sing it for you. What? I honestly, I wouldn't, if I heard it, maybe, but I honestly couldn't tell you a song. Okay? Alright? So, let's talk end behavior. So, based off of this first function, f of x equals x cubed, what is the shape going to look like? What's the shape going to look like? Mainly I'm talking the left and the right sides. One's going to go up and one's going to go down, right? Okay. What about the second one? Same thing. One up and one down. Okay. So let me bring the sketches into play. Or I actually graphed them. Maybe I did. Where did they go? They were on here. So there is x cubed. There they are. So here is x cubed. And here is the other one. Again, Colin, you raised a good question before. Can we have fractions and decimals in these standard forms? And the answer is yes, we can. Okay. All right. So, oops, I forgot to bring this down now too. This is riveting internets. There we go. Okay. So, what I want to focus in today on is, I want to focus in on end behavior. And end behavior can be defined by the degree if it's odd or even. In this case, it is odd because it's 3. Okay, my degree is 3. And it also can be defined by my leading coefficient. My lead coefficient is the number out in front, and in this case, it is positive. So because of that, the end behavior, and this is how this is going to be read, how you are going to read it back to me, how you are going to write it on your paper for answers, or in your homework tonight, or on a formative next week, or on a quiz in a couple of weeks, or on a test in November. Okay? So, for this first one, let me bring it down a little bit because we can see the functions on the graphs. Okay? So this is how it's written, spoken, and given as an answer. Okay? As x goes to positive infinity. So this is my x axes right here. So as my x's go farther and farther to the right, my function goes to positive infinity because it's, as I go this way, my function is going up. So if you had to write this, you would not just write positive infinity. You would write as x goes to, with that arrow, the goes to is the arrow. So as x, arrow, positive infinity, comma, f of x, arrow, positive infinity. Okay? And it's read as x goes to positive infinity, f of x goes to negative infinity. So that's the right side. Now the left side, as x is going to negative infinity, so I'm going to the left now, my function is going down. So that's going to negative infinity. So if you have an odd degree function with a positive lead coefficient, your end behavior is always going to look like that. If you have an odd degree function with a negative lead coefficient, as x goes to positive infinity, so as it's going to the right, my function is going to negative infinity. And as x is going to negative infinity, otherwise known as the left, my function is going to positive infinity. Okay? Let's try even functions now. Okay? So here are those. Okay. So the end behavior of the first one, well, that has an even degree. So they're going to end up going in the same direction. It has a positive lead coefficient. So they're both going to end up going to, as x goes to positive infinity, as I go to the right, my function is going up. And as I go to the left, my function is going up. So as x goes to positive infinity, f of x goes to positive infinity. And as x goes to negative infinity, f of x goes to positive infinity. You have to write them both out. Okay? And you write them out like that. You can't just say, in positive infinity. Okay? You will be marked wrong because it's not proper mathematics. Okay? On the other one, on the second one, now I've got a negative lead coefficient. My degree is still even. So they're both going in the same direction, both sides, but now they're just going down. So as x goes to positive infinity, my function goes to negative infinity. And as x goes to negative infinity, my function goes to negative infinity. Okay? Good times. Okay? So basically, to sum it all up, okay, you got to ask yourself two questions. What's the degree? And what's the positivity of the lead coefficient? So if the degree is odd and the lead coefficient is positive, it's going to look like this. Okay, it's going to go up and to the right, down and to the left. If the degree is even and the lead coefficient is negative, they're both going to go down. Okay? If the lead coefficient is positive, no, I did positive right. If the lead coefficient is negative and the degree is odd, it's going to go down and to the right or up and to the left. And if the even degree, positive lead coefficient, they're both going to go up. Okay? And end behavior is just looking at the right side and the left side. Of your graphs. Okay? You have this written down already. If it's odd with a positive lead coefficient, that one goes to positive infinity, that one goes to negative infinity. If it's odd degree, negative lead coefficient, as we go to the right, it goes down to negative infinity. As we go to the left, it goes up to positive infinity. But again, you have all of that written down already. If it's even, positive lead coefficient, they're both going to go up to positive infinity on both sides. And if it's a negative lead coefficient, both sides go down. Okay? So, tonight on your homework, I am going to ask you to sketch 4 functions. And you can do that right in your notes or right on your homework page. You don't need an extra set of graph paper to do that. So I would like to do one right now. So sketch me what that function is going to look like, and then tell me what the end behavior is. So, what's my sketch going to look like? Work left to right. So on the left side of my graph, it would be going up. On the right side of my graph, it would be going down. So it's going to look like something like that, right? Okay. All right. end behavior of that then is what?
As x goes to the
So as x goes to
positive infinity.
positive infinity, so which way are we going?
To the right.
To the right. I said f of x.
F of x goes to negative infinity.
Do we agree with that? Do we agree with how she spoke it, too? Yeah. Okay. Can somebody else give me the other one?
As x reaches negative infinity, f of x reaches infinity.
So as x goes to negative infinity, f of x is going to, you said positive infinity? Okay. It's a thinking day. It's a thinking homework. Okay? There's not a lot of math in this homework, if memory serves me right. Okay? But there's a lot of thinking. Okay? So here is that homework. That homework will be due next week, Monday. Oh, and then I also wanted to add, too, that there are 4 graphs that you can just sketch. If you want to put them on a piece of graph paper, you can, but you don't have to. Did I get in it? Good times. Yep.